Good morning students. In last video we have already solved question number 1st, 2nd and 3rd of exercise 13.1. Today we will solve other questions of this exercise. Let's see question number 4. A cubical block of side 7 centimeter. So here is a cubical block of side 7 centimeter is surmounted by a hemisphere. Surmounted by a hemisphere. What is the greatest diameter? What is the greatest diameter the hemisphere can have? The hemisphere can have. Okay, then find the surface area of the solid. Find the surface area of the solid. Okay, so I think this type of question, one example is we also solved. So see the figure button. Now a cubical block of a side 7 centimeter. A cubical block. So here you see, this is the figure. This side here we draw the figure. So this is a cubical block. This is a cubical block which is surmounted by a hemisphere. Okay, this is a cubical block which is surmounted by a hemisphere. So here first question said what? Now what is the greatest diameter of the hemisphere? So here you see, now the edge of the cube or this one is 7 centimeter. This edge is also 7 centimeter. So you see here, now the greatest diameter of the hemisphere which is surmounted on the cube, that is also 7 centimeter. So here we write from the figure, the hemisphere can have greatest diameter. Solution in the or from the given figure, from the given figure, the hemisphere can have greatest diameter, that is equal to how much? Is equal to 7 centimeter. That means here we conclude what? Now the edge of the cube, that is 7 centimeter, and the diameter of the hemisphere is also 7 centimeter. So then the radius of hemisphere is equal to how much? So the radius of a hemisphere is equal to 7 upon 2 centimeter. Okay. Then here you see the question again said what? Find the surface area of the solid. So here you see the cube having 6 faces. So the first you find the surface area of the cube, then plus curved surface area of the hemisphere, and last part here you always remember when a sphere surmounted on a cube, so then the base area of the hemisphere will be removed. Okay, so here first we find now the surface area of the solid is equal to what? Now the surface area of cube plus curved surface area of a hemisphere minus the base area of the hemisphere. The base area of hemisphere. So, all of you know what is the surface area of the cube? Total surface area, that is 6a square plus curved surface area of the hemisphere 2 pi r square minus the area of the base of the hemisphere, that is pi r square. So now it is 6a square plus 2 pi r square minus pi r square, that is pi r square. Okay. So now 6 into a means that is the edge of the cube, that is 7 into 7 plus pi. Here it in the question it is given pi is equal to 22 upon 7 into r square, that is 7 upon 2. Here r is 7 upon 2 into 7 upon. Now it is what? 7 49 into 6. So okay, then here it is we conclude what? Now 7 cancel. So here you see 7 cancel, 2 11. So here 7 49 into 6, that is 2 49 into 6 4 294, that is centimeter square plus here it is 11 into 7 77 upon 2 centimeter square. Okay, so that is equal to how much? 294 plus 77 upon 2, that is 2 3 plus 6 17 2 8 60.5 centimeter square. So that is equal to how much? 0.5 332.5 centimeter square. This is the total surface area of the given solid, where the solid is in which shape? Now first, this is a cubical block which is surmounted on a what? A hemisphere. Okay, so this is the surface area of this block, that is equal to 332.5 centimeters. Okay, then come to, I think all of you understood, then come to the next question, question number 5. A hemispherical depression is cut out from one face. A hemispherical depression is cut out from one face of a cubical, one face of a cubical wooden block such that the diameter L of the hemisphere the diameter L of the hemisphere is equal to the age of a cube. Okay. Determine the surface area of the remaining solid. Determine the surface area of a remaining solid. Okay. So here this is the question, but now hemispherical depression is cut out from one face of a cubical wooden block. So here you see this is a cubical wooden block. This is a cubical wooden block and a hemispherical depression. So here you see a hemispherical depression is cut out from one face of the cube. Okay. So a hemispherical depression is cut out from one face of the cube. So here the remaining surface area means that is the surface area of the cube. Then it is depression means it is cut out from this. So the inner hemisphere, the surface area of the inner hemisphere, and but now this portion, this portion is also the remaining portion. Yes or no? Okay. So now here you see, and here it is one condition is what? The hemisphere, the radius of hemisphere, no, the diameter of hemisphere and the age of the cube both are the same, that is given, that is L. Okay. So age of the cube, so here you write first age of cube, that is equal to L. So what is the surface area of this cube? So the surface area of cube, that is equal to 6 into h square. So that is 6 into, here h it is given L, that is L square, that is 6 L square. Okay. Then what? Now here according to the question, the diameter of the hemisphere is also L. This is L, and the diameter of the hemisphere is also L. So here you write according to the question, the diameter of hemispherical depression is equal to L. So then the radius is equal to L upon 2. Okay. So what is the, so this part, this is the depression is cut out. So that means here it is make a inner curved surface area of hemisphere. So first you find curved surface area of hemisphere, then the remaining portion. So here you write curved surface area of hemisphere, that is equal to 2 pi r square. Then what? Now the area of the circular base, the area of a base part, this is also removed. So then the area of a base, or the base area of a hemisphere, base area of a hemisphere, that is equal to pi r square. So the remaining part, or the, here is question said, but determine the surface area of the surface area of the remaining solid is equal to what? The surface area of cube plus inner curved surface area of a hemisphere minus base area of a hemisphere. Base area of a hemisphere. So what is the surface area of a cube? Now 6l square plus inner curved surface area, that is 2 pi r square minus pi r square. So that is equal to 6l square 2 pi r square minus pi r square, that is pi r square. So then here you write. So here also you find what? 2 pi r square, that is equal to 2 into, okay, pi is in, here you take only pi. R is equal to how much? L upon 2. So L upon 2 whole square. Okay. So here also we find what? You take here. Okay. So 2 pi L square upon 4. So here you please cancel. That is 2. So pi L square upon 2. So this is also pi R square. So that is pi into L upon 2 square, that is pi L square upon 4. This one. So here if we take put this part 2 pi R square minus pi R square, that is plus pi R square. So then it will be what? Now 6L square plus pi L square upon 4. Okay. So then LCM is equal to 20. LCM is 4. 4 into 6, 24 L square plus pi L square. Okay. So then here we can write that is equal to 1 upon 4. You take common pi. No, you take common L square. So then 24 plus pi. Okay. So 24 plus pi, 1 upon 4 into L square. So here also we can write L square upon 4, 24 plus pi square. Okay. So the area of the remaining solid is equal to L square upon 4 whole into 2 pi plus 4. If here we put 2 pi r square minus pi r square only plus pi r square, it is there. If otherwise you put this minus this also. Okay. So the always you remember on a cube when a curved surface is surmounted or a hemisphere surmounted or a hemisphere cut out. So in both cases the base part of the base area of the hemisphere always removed. Okay. So then it is the surface area of the remaining solid, that is equal to L square upon 4 whole into 24 plus pi square. Okay. So I think all of you understood. Then come to next question, question number 6. Question number 6. A medicine capsule is in the shape of a cylinder. A medicine capsule is in the shape of a cylinder with the hemispheres stops to to each of its ends. The length of the entire capsule, is 14 mm, and the diameter of the capsule is is 5 mm. Okay, then find the surface area. Find the surface area. Okay. So now according to the question, here it is a capsule which is in the shape of a cylinder, but both the end are in the shape of a hemisphere. So this is the capsule. Okay, and the total length of the capsule is 14 mm, and the radius or the diameter of the capsule is 5 mm. So here both ends, these are the hemisphere. So if the diameter is 5 mm, so the radius of the hemispherical part of the radius of the capsule is 2.5 mm. So here you see this end 2.5 and this end also 2.5 mm. So then only, so this part is the cylindrical part and these two ends are hemispherical part. So only the length of the cylindrical part, this part is equal to how much? The total capsule length is 14 mm. So here 2.5, here 2.5, both are subtract. So 14 minus 2 into 2.5, that means 5. So then the length of the only the cylindrical part is 9. Okay. So now we can find what? Now the surface area of the capsule. So here we write the radius of total length of capsule, that is equal to 14 mm, and the diameter of capsule, that is equal to 5 mm. So the radius of the capsule is equal to 5 upon 2, that is 2.5 mm. Okay, so here the capsule is in which shape? Now this is in a cylindrical shape and both ends having two hemispheres. Okay, so the total surface area of the capsule, that is equal to what? Now the chord surface area of the cylindrical part plus 2 into curved surface area of a hemisphere, because here two hemispheres are there. So curved surface area of a cylindrical part plus 2 into curved surface area of a hemispherical part. Hemispherical part. So that is curved surface area of a cylinder, that is 2 pi r h plus 2 into curved surface area of the hemisphere, that is 2 pi r square. So here 2 pi r h plus 2 into 2, 4 pi r square. So that is, here we take common. So 2 pi, that means this is what? Now 2 into pi and r to take common. So it is h plus 2r. So that is equal to 2 into 22 upon 7. R is 2.5 into the h means the length of the or the height of the cylindrical part, that is 9 plus 2 into 2.5. So that is equal to how much? 2 into 22 upon 7. Here it is 2.5 into 2. Okay. So 2.5 into 2, that is 5 into 22 upon 7. Here it is 5 plus 9, that is equal to 14. 7 cancel 2. So that is equal to 5 into 2, 10. 10 into 2, 220 mm. Okay. So the surface area of the capsule is equal to how much? 220 mm square. Okay, square unit. So that means first you find the capsule is in the shape of a cylinder and both end having two hemispheres. So the surface area, simply you find the curved surface area of the cylinder plus 2 into curved surface area of the hemisphere. Okay, so I think all of you understood. In next video we will solve the next 3 questions, 7, 8 or 9. Okay, thank you.